So this is a sort of supplemental video on the mole concept and Avogadro's number. This is to supplement the boot camp video on moles that you have already looked at and presumably done some problems associated with. Some students struggle with the mole concept. Some students get it right away. One of the things I struggle with is exactly the best way to teach it because different people understand it differently. And so I just kind of see if I can throw as many different, uh, sort of come up with as many different ways of throwing this at you as I can and hoping that some of it sticks. And so this is sort of supplemental to the boot camp video. Um, we talked about this. If you're at St. David's watching this, we talked about this in class that the atomic mass unit, which is what we think of when we're figuring out the mass of atoms and we're figuring out the mass of molecules. An atomic mass unit is equal to 1.66 times 10 to the minus 24th grams. And so we can create a ratio out of that, 1 AMU per 1.66 times 10 to the minus 24th grams. Well, when you divide by something, it's the same as multiplying by the reciprocal of that thing. And as it turns out, the reciprocal of 1.66 times 10 to the minus 24th is 6.02 times 10 to the 23rd. And so there are 6.02 times 10 to the 23rd atomic mass units in 1 gram. And that's really the origin of Avogadro's number. That's how it was finally worked out what its value was. So just to reiterate what this means, a mole of atomic mass units, if you've got Avogadro's number of atomic mass units, you have a gram. And so that's the key fundamental relationship. And so therefore, what we're able to say then is that the mass of 1 mole of anything is expressed in grams. And when we're saying anything, we're not talking about shoes or cars or things like that. We're talking about atoms or molecules. The mass of 1 mole of anything expressed in grams is equal to its formula mass expressed in atomic mass units. And so this is actually the term that when I first started teaching chemistry about 10, 12 years ago, the term that had stuck in my mind from somewhere back in probably in college for me was the idea that a teacher had defined it as a mole is the gram formula weight. And so what does that mean? That means that the molar mass of any substance, that is the mass of 1 mole of that substance, is equal to its formula weight, simply expressed in grams instead of expressed in atomic mass units. There's another really important thing to remember, so important that I bolded it here in the next bullet point I'm going to bring up. And this is what's really the power of the mole. And that is that 1 mole of anything has the same number of particles as 1 mole of anything else. If they're different substances, a mole of each doesn't have the same mass. A mole of water weighs 18.02 grams. A mole of carbon dioxide weighs 44.01 grams. We get these numbers from the periodic table. But they have the same number of particles. And at the end of the day, the mole concept isn't really about calculating how many atoms of this you have or how many molecules of that you have, although the AP curriculum requires you to be able to do that. The power of the mole is to be able to, at least for a practicing laboratory chemist, is to be able to allow you to work out mass relationships in chemical reactions. That's called stoichiometry. That's going to be the next topic we're going to get to, not in this video, but in the class. So let's take a look at some examples. The next 3 or 4 slides are actually from the publisher's slides that go along with your textbook. And so we're talking about water and saying that a single molecule of water has a mass of 18.0 AMU. Therefore, if we've got Avogadro's number of them, since Avogadro's number of AMU adds up to 1 gram, if I've got Avogadro's number of a thing that weighs 18 atomic mass units, it's going to weigh 18 grams. So we're going from a single molecule to a laboratory size sample, and so a mole of water weighs 18 grams, or to 2 decimal places, 18.02 grams. A mole of carbon-12 has a mass of 12 grams, and in fact, that's not 12.000 as if it only had 5 significant digits. That's actually the definition of a mole. Um, that's actually the definition of, yeah, so that's a definition of a mole. A mole is equal to the number of atoms um, of the mole is equal to the number of atoms in 12 grams of carbon 12. And so that's what a mole is defined as. And so actually a mole of carbon 12 has a mass of 12.000 out infinitely. Um, so by definition, the molar mass of a substance is simply the mass of one mole of that substance. And so that is simply going to be, this is sort of redundant from what we've already said, but sometimes we can't say these things enough. If you want to figure out the mass of one mole of anything, you look up all the elements on the periodic table, you multiply by how many atoms of each of those elements appear in the formula, and then you work out the mass of one molecule in AMU, and then you simply say, okay, now I'm going to convert the unit from AMU to grams, and now I've got a mole of it. So the formula weight in atomic mass units will be the same as the molar mass in grams. And so that goes back to this. The formula weight of water in atomic mass units is 18.0 AMU. The molar mass of water is 18.0 grams. This is simply equal to roadmap 1, which is in the boot camp in the video, but also I had a copy of the roadmap in the files, worksheet files for the boot camp. And this is what allows you to convert between moles and grams, and to convert between moles and formula units. It's often simple just to say molecules. But when we say molecules, we're really talking about molecules in the case of a molecular substance, atoms in the case of an atomic substance, etc. So moles here are providing a bridge from the molecular scale, that is the formula unit scale here, to the laboratory scale, in which we have things in grams. And so here are some examples. An atom of nitrogen weighs 14 atomic mass units. Therefore, a mole of nitrogen weighs 14 grams. And that gives me, and that's 6.02 times 10 to the 23rd nitrogen atoms. A molecule of nitrogen, because it's got 2 nitrogen atoms, weighs 28 grams. 28 atomic mass units. A mole of nitrogen gas weighs 28 grams. Again, I've got the same thing, 6.02 times 10 to the 23rd nitrogen molecules. That goes back to that big bolded thing I had that said the 1 mole of anything has the same number of particles or molecules as 1 mole of anything else. If I've got a mole of if I've got 1 silver atom, that weighs 107.9 grams. If I've got 1 mole of silver, I'm sorry, I keep messing up the units here. If I've got 1 silver atom, it weighs 107.9 atomic mass units. If I've got a mole of silver atoms, it weighs 107.9 grams. And again, I've got Avogadro's number of silver atoms. If I'm talking about barium chloride, which is an ionic compound, 1 formula unit of that is 1 barium atom and 2 chlorine atoms, weighs 208.2 atomic mass units. A mole of barium chloride weighs 208.2 grams, and I've got Avogadro's number of barium chloride formula units. So 1 mole of atoms, of ions, or of molecules contains Avogadro's number of those particles, etc. So let's take a look at, so this is kind of the end of just kind of trying to present this to you. Again, you've seen it in a different video, presented in a slightly different way. The hope is that between all these things and reading your textbook and talking to me or whoever your teacher might be, you can come to get your brain around the mole concept. One of the things that that you may be asked to do that hasn't been addressed in these slides yet and wasn't addressed in the boot camp slides is not calculating the number of, say, molecules of a thing or formula units of a thing, but calculating the number of atoms. And I'll show you what I'm talking about. So in another presentation, we talked about ethane, which is a molecule hydrocarbon that has the formula C2H6. And so you could you could be posed with the question, how many ethane molecules are there in 10 grams of ethane? And you would use the roadmap and convert from mass to moles, and then from moles using Avogadro's number to molecules, and that would tell you how many molecules there of ethane there are in 10 grams of ethane. What this question is actually asking you is something slightly different, which is how many carbon atoms are there in 10 grams of ethane? So let's see how we figure that out. And then a second question would be, well, what's the total number of atoms in 10 grams of ethane? Well, to answer both of these, we have to come up with an additional conversion factor, which is how many atoms of the element that we're talking about are there in one molecule? And for ethane, and we're talking about carbon, there are 2 carbon atoms for every ethane molecule. And if we're asking for the total number of atoms, there are 8 total atoms, 2 carbons and 6 hydrogens in one molecule of ethane. So that will help us answer the question here. So I start with 10 grams of ethane. I divide by its molar mass. That tells me how many, at that point, I've determined how many moles of ethane I've got. I now multiply by Avogadro's number. That's going to tell me how many molecules of ethane I've got in 10 grams of ethane. But then I need to apply this additional conversion factor, which is that there are 2 carbon atoms for every molecule. And when I work that all the way out, that gives me 4.01 times 10 to the 23rd atoms of carbon in 10 grams of ethane. What's the total number? What's the total number of atoms in 10 grams of ethane? Well, it starts out exactly the same. I take that 10 grams of ethane and divide by its molar mass. That tells me how many moles of ethane I have. I multiply that by Avogadro's number. That's now going to tell me how many molecules of ethane I have. And then, because there are a total of 8 atoms, 2 carbons and 6 hydrogens in every molecule of ethane, I've got to multiply by that conversion factor, and that gives me 1.61 times 10 to the 24th atoms. So I threw this slide in because this is the kind of problem you see in your textbook, and you may also see it on a test, and you may also see it on the AP exam. So it's important for you to understand how to do that calculation. Okay, thanks so much for watching.